quickly a bit about myself. I worked 14 years in the simulation industry and in the game industry. I worked on different game engine and middlewares. And also I did some videos in Laundromat on my spare time with bands. About Unity, yeah, something interesting on the backside. Do you know what are the game engines on the top right there? I didn't. Yeah, anyone knows? No. So it's on the left. It's Gamebryo there on the top left, and then just on the right it's Virtuals. So it's kind of two game engine who kind of died. Um, I worked also for a company who was making the AI for renderware, which is again game engine who died. So game engine have been around for quite a while, um, and yeah, it was time where Unity was very small. So yeah, you will see that the point now is not to make a game engine really, but just to what Unity achieved, like to create an ecosystem around the game engine and to create a community. It's super important. So about Unity technologies, so we have no offices in a lot of countries, and I'm based in one which is not showed in Paris in the middle. It's my home, but it's so that's why it's not showed. We are 500 people working for Unity right now. About you a bit, who is using Unity already? Oh, okay, who is not using already Unity? Okay, who is using Unity 5? Okay, okay, so that's gonna be interesting. Someone tried it? No, you just tried it. Okay. So about you users of Unity, you're among 3.3 million people who registered to use Unity, and probably here you're among the 600,000 people who are actually using it every month. And I'm field engineer, so I'm traveling around Europe to visit users, and it's interesting to see that I meet all team sizes from like 1 people. Usually the band size is a good one, or like 4 people, and but I've seen teams of like 10, 20 people, and mixed people also using Unity, from veterans developers and until even some kids sometimes. About game made with Unity. So which one is not made by Unity? With Unity. Okay. Any other guess? No. Okay. Actually, they are all made with Unity. That was a trick. But I think what is interesting here is the fact that, yeah, you don't see that it's Unity on. I don't think you see it's Unity on any of the images. It's like completely different styles on everyone. And as an engineer, it comes from the fact that Unity builds like just the core component, and then everybody's doing on top. We try to not take we just build like classical technology and cutting edge technology also, but not trying to make a game. We're just trying to give technologies. One Want to mention just funny things, like I'm based in France, so I will preach my country. Do you know which one is on the second row on the left? No, it's Endless Legend by Amplitude Studio, and yeah, they did quite a good job on the rendering. Like most of the engineers were working on custom engine before, and they just customized. They did their own terrain system and almost like half of the rendering of the terrain system themselves. It's quite interesting to see that if you really want to customize everything, you can achieve something quite good. Yeah, also we don't only make game with Unity. There are many transmedia projects coming in. Even in the middle here on the top, there is it's on TV. It's just on French TV, French German TV, Arte. Somebody did an animation made with Unity just for the French TV, not even to have anything interactive. So let's go into Unity 5. So why Unity 5 is easier? First, the new GUI, but probably who tried the new GUI here? Okay, so is it easy or? Yeah, okay. There is a new audio mixer. I try to show this. So I made with a GUI. I made just a small synthesizer. So I made a small synthesizer with the new GUI and just putting the GUI into the world space. There is almost no line of code because it's just triggers, the buttons triggers things, and to change the pitch, I just use the event system to do that. And in the end, I just ended up making some code so that I don't have to write the name of each key and so on. But basically, you could do this without code. So if you play that, we have a new component here, which is called the keyboard mixer, the audio mixer, sorry. So it's just like an audio mixer in real life, where you can add mixers and sub-mixers, which you cannot do in real life on the hardware. And what you do is like for every keyboard there is a speaker with a sound with an audio source, and when you create your subgroups, you can output it to any slot in the mixer. So here I put on each synthesizer one slot. Let's put it here. So if I play that and go and look at the mixer, I have an edit in play mode for this component, so you can change it live. And you can play the second one. So you can control everything live. The master, you can put it in a subgroup, and we have also a bunch of effects that you can add, which are already here, like I don't know, a distortion, for example. Or you can choose. Oops, sorry. It's party. And you can expose these parameters. Okay, it's already exposed, but you can expose all the parameters of the effect into the mixer, so you can have access by script to every parameters of the effects. So it's very nice. Also, what is good is when you do a setup of your sound. So everything. So the sound designer can really work in one place. The game designer will just link the audio sources to the right mixers, and then the sound designer will be able to work on these mixers. And then you can, when he has a good sound, you can take a snapshot of the levels, and then you can blend between two snapshots to change the ambience live. So it's quite nice. Also, something which is new is the fact that the audio clip now in Unity 5. Oops, sorry. Party was hard on me yesterday. The audio also is just like texture now. You can choose per platform configuration and have Vorbis compression on mobiles. So that the audio. Oops. Mechanim, we are going in a way where the Mechanim state machine is becoming also just a general state machine that you can use for something else. And to do that, you just have to. There's no animator here. So you can add behaviors to the states. So for example here, right now, like in Unity 4, the state is just running a motion, and in Unity 5 you can actually add just a behavior to this. So you add a script, behave, and okay. And if you look at this now, you have a bunch of interface of callbacks on the behavior, so you can really code your own behaviors directly into the state machine. So the coder codes the behavior, and then you can play around a bit like visual scripting, but with states in a hierarchical state machine. It's also a real hierarchical state machine now, because we have an entry point and an exit point for every state. So you can just put the state hierarchically. Does it exist hierarchically? Yeah. 2D physics effectors, that's just basically between Unity 4 and Unity 5, there were not many changes in the 2D system. Some bug fixes, but just adding some physics effectors so that when you enter a zone, which could be a radius or just a rectangle, then you can add a force to every object passing through the zone. So if you want to have an accelerator, or if you want to have a repulsor, an attractor, it's just now just one component to add to your object. We improve the asset bundles also. We want to push the asset bundles to be the center point for your resources management. So in Unity 5, we like an asset bundle is just a bunch of assets that you put into a kind of zip, but then all the work in Unity 4 has to be done by your. So we added some API so that you can manage all the dependencies. So you can push pop the dependencies when you are building your asset bundles. So for example, something simple we changed also is the fact that before almost everybody was just adding a component or adding a script just to know in which bundle something was supposed to go. So right now we have added in Unity 5 this, where you just say this is level 2 materials. Oops. And then you can choose, for example, to just select all of them and say, I want all of them to be on the level 2 materials asset bundle. And in your API, you just have to say, build asset bundles for level 2 materials, and it just take all these assets and put it into one bundle. And then if you have a dependency, you would just say, push all the level 2 materials, and then you will push the prefabs from this level, and for each prefab, the materials won't be included because we know that they have already been included into another asset bundle. And asset bundle is very important to manage the streaming of your assets. If you're making something online, just to grab the new levels from the web. You can also, we have a versioning system, so you can update some of the assets with asset bundles. So it's very central in Unity 5. We have added standard shader and physical based shader. So basically here in this example, so what is a physical based shader? It's just actually like a normal shader usually just takes the normal light, and the physical based shader just take the environment and will compute how much energy has been absorbed by the material and how much energy it's giving depending on the angle where it's seen. So it's just like physical lighting equations, which are standard now. And what it allows is that if you take your characters or anything into a different environment, it will be always kind of coherent with its environment. If you don't use that, it's going to be like a photo collage, where if you take a picture of me here and then you put it down at the stand, you will see that I'm not on the right place because my image is not dependent on the environment. So I will show that here. So this is the robot from Unity, I think 3 demos in Unity 3. If you look at the shader here, it's an Uber shader. So before that, you had to choose between all that, and now you just basically most of the time you play with a standard shader. We have two setups, specular or metal, and you can just play around with every parameters. Add a normal map, add an 8 map if you feel like, add details and everything, and then we just compile the right shader in the end depending on what you used. So it's not one shader for your entire game, but it's just like we are the implementation of the shader is hidden behind the standard shader. So it creates the best shader for you. So let's see. Where? Yeah, maximize. So you see, if I change the environment, you see that when it's kind of in a cold environment, you really feel like the robot is in this environment here. And when it's on a warm one, it works also. The bloom is like, it's very strong. We can have also, we can push the emissivity if you want something a bit AAA. A lot AAA. Yeah, so you just play around all these parameters here, and you can just transform it anytime into something which looks more like polished metal or a bit more plastic, kind of. So it's the first time in my life I actually start having fun with shaders. Yeah. So it's very nice. And yeah, like, and for a lot of people are asking if it works on mobile. So it's just it depends on the GPU if you can execute the equations. But like I have on all my tablets, it's working nice. This demo, no problem. But if you do an RTS, maybe you cannot use the standard shader for like 200 entities on screen. But yeah, we have the frame debugger also, which makes things a lot easier to debug. So before, I think in Unity 4, when you look at your stats, and you are like, okay, like here it's alright, but if you look at the draw calls, you're like, okay, it's a lot of draw calls. I have no idea why. So you just go and deactivate some stuff and see where the big number of draw calls is coming. In Unity 5, you just enable the frame debugger, and then you can go through every draw calls and see exactly what happens. You can also debug your shader this way. Like here, we can see what the bloom is exactly doing. We can also just tweak the range of colors. For example, if you want to debug a low range of values, you can just select what you want to see. Yeah, it's not super relevant here, but so it's quite good. You can also see each channel individually. You can see the render textures, depth texture. So it's only in the editor, but the goal is just to see what is happening. Is my game alright? Is there an asset which is not well made because there are too many materials? Are there too many materials which are not shared enough between your components? So it really gives you the access to optimizing your draw calls very quickly. So that's all what makes Unity easier. What makes Unity better? We integrated Enlighten into Unity. It used to be based on Beast technology before, and now it's Enlighten, the same as in Unreal and a lot of game engine used in the AAA industry. And it it brought like a better rendering, better light mapping, and also runtime global illumination. So some examples. This is done into Unity with a new baking. These are assets from GTA which were brought into Unity and baked there. So yeah, we can really achieve super good results now. Also we have the reflection probes. So on the robot demo, the environment is taken by the cube map, but like if your game is fully 3D and there is no cube map, you want to have the right environment, so you just add a game object, which is a reflection probe, and I will open the project at the same time, and which will just compute a cube map at this point. It will just take pictures everywhere. So I will show you an example of that. So here, for example, I just put a reflection probe, which is just a game object with a reflection probe component, and this computes the cube map here. And then I just assign. I just made the material for this sphere very reflective, and then since it's inside the range of this map, you can see it in very light yellow. Wow, we don't see it on screen, but there is a box which will say everything inside of this box will be affected by this environment map. So, and if you have many of them, we blend between them so that if you want to reflect everything which is along a wall, you just put like a few reflection probes, and you will go through the wall and you will change the reflection. So here in this example, it will bring another topic later on. So here I used like runtime reflection, real-time reflection probes. So it's just you have a few modes for the update of the reflection probe. It can be baked, so it's just the same all the time, and it can be dynamic. So you can decide when to refresh it. So here I want to refresh it all the time because I want to see the balls coming in. But for example, if you have a level, if you want to do a skybox with day and night changes, you can just, for example, bake your environment map every cycle of changes. So that's it. It's slow motion, that's why it's slow. It's not because the frame rate is low. We also, when you do the baking of the light map, the problem is like if you do the global illumination, your character, when he will travel inside this universe, when it's close to red wall, when it's close to the red wall, it won't receive the illumination from the red wall because it's not globally illuminated. So we have light probes. So you just put a few lights which are recording the light at this position, the light color at this position, and that will give back the color from the wall onto the character. I just have 5 minutes, so I cannot show it. So we have also a speed tree integration. So there is a small tree editor made by SpeedTree, which is integrated into Unity editor. It also makes the integration of the SpeedTree library of trees directly into Unity, so you just can buy nice trees and then just bring them into Unity. We have a new cloth system, very simple. You just take a skin mesh and then you just choose the constraint. I want this to be attached and not moving. I want this to just move a bit, or I want this close to collide with a list of colliders, and you just give the list of colliders. So it's very efficient because it doesn't collide against the entire world. You just give yourself the list of colliders it will collide with. It's multi-threaded, so we see that. We have the 64 bits editor, so if you have a very big map on the same scene, you can put a lot more. I think now if you start breaking the 64 bits limit, it means that there are really too many things in your scene. So faster. So there is multithreaded physics. We can see that on this example actually. So when we spawn, like this demo typically is running on an iPad, and what happens is if you put it the same on Unity 4, it's just the frame rate just drop and drop after a few seconds because it cannot handle everything, and this is due to the fact that Unity is multi-threaded in Unity 5, and you have also that in the profiler. So you can see if I stop at some point here, I can just go and see that on every thread, oops, I have some worker thread treating the physics here. The the skinning also is multi-threaded now, so you can put a lot more characters. I don't know if you played Gang Beast. Who played Gang Beast here? Nobody? Okay, yeah. You should play Gang Beast. It's nice. It's a party game where it's very physically heavily based on physics because it's like ragdoll and all the movement are just applying forces to the arms, and moving is just moving the legs. And so it's like super heavily skinned characters, and just going from Unity 4 to Unity 5, like they gain like 5 times performances. I have a video of that. Here. So like they put a lot of characters like this, and this used to work around 10 frames per second in Unity 4, and now it's running quite well. Then we have so audio format platform. I show that we have IL2CPP, which is a technology which allows to convert your interpreted language into C++. So to go from the interpreted runtime to the ahead of time compiled code. We have metal optimization. Metal optimization is backported also in Unity 4.6. So it's coming soon. It's on alpha right now, and it will come soon to 4.6 also. We work also to integrate the Intel x86 support for mobile devices. There's like 60 millions of tablets, I think, having this chipset. We also just released last week officially on 4.6.2 the 64-bit support for iOS, and this was done with IL2CPP, which is this technology, which is the technology that we will try to use in every platform going through the time. So right now it's iOS, it's WebGL, and it will be Android and consoles and standalone, so that you can have ahead of time compiled code into your final build. And stronger, so where you're stronger, that's a good news, I think, for a lot of people using Unity now. So like when you save the scene in Unity 4, sometimes it's kind of reordering stuff and you don't know why. We didn't know neither, so we fixed it. We have a YAML semantic merger, which allows to merge two YAML. So it means that if you have two things we changed, somebody changed like a value somewhere and somebody else a value somewhere else, it's very hard to tell if it's actually some component of the same game object or if it's like two different game objects. So we have added this semantic merger that will tell you if there is a risk that it's the same game object or if it's just not the same game object, and you can decide if you want to backport the two modifications. So it will just tell you a bit more than there is a conflict. Just it's better than just saying two people modify this file. It's two people modify the same game object or related game object. Unity Pro is free if you develop for this platform, like to deploy on these platforms. It's free. Used to be something like 40K for Xbox, and now it's free. Basically, Sony and Microsoft and Nintendo are paying the Pro version for these platforms for you. WebGL, which is coming very soon and will change, I think, quite a lot the tomorrow's web interactivity. So just basically you launch Unity into the browser and you don't have to install anything. It's close to native performances. You can do full screen play. Most of the people until now they have almost the same performances as on the native installation. So it's super impressive. And it's we have made an Oculus partnership so that we can bring Oculus to the free version. So that's the first step. And then the second step is to integrate Oculus directly into Unity, so that it becomes a kind of platform where you deploy to Oculus. You deploy to VR the same way you deploy to a mobile device. And Unity is not only an engine, you know that. We have a lot of services, cloud build, so you just give the address of your repository and we make the build for every platform for you. We send you an email when it's done with a link to the application. It's in beta, it's free right now, and yeah, try it, it's super good. We have a dashboard online where you can see what is happening. So each time someone does a commit, it launches a new build, and you receive a mail if the build failed. So it allows really to monitor on every platform your project, even if you don't. Like most people work on one platform from start, and then they move to the other one, and then they forget about it, and then they move back to the other one. So here, day one, you just cloud build on every platform, so you're sure that anytime you want to switch, it's going to build. Unity ads, there will be a talk about this. Every play also, yeah. And analytics, there will be also, no, there won't be a talk about it. It's about cloud build, so if you want more details. And analytics is just in beta right now, so you just also the same principle. You go online, you just create an account on analytics.unity3d.com, and then you receive an ID that you put in one component, and this is done. You're connected to the analytics system, and you receive all the retention number of your users. You can do funnel analysis. You can have trigger in your game to know how many users went to level 2, 3, even to some spaces. So you can do that. And we have a new service which is not here, which is Unity Cloud Data, which is just like kind of public parameters in your game that you can monitor from the cloud. So same thing, you can have, I don't know, the speed of your character, for example. It doesn't make sense, but you can have fun making jokes to people playing with your game, having the speed of the characters managed from the cloud and changing it live, and it's changed the speed for everybody who's using it. So, yeah, that's all. Thank you for your attention.
Cool. So I mean, I feel sorry for rushing things along.
Yeah.
We have so much stuff in Unity 5. It is absolutely impossible to fill it in half-an-hour slots, but that's what we have. So obviously, you know, Matthew's around. Please talk to him. Talk to any of us. We have some great stuff going on. I particularly like the public parameters. I remember with PlayStation Home, we had this big head setting, so we only used very infrequently, but it was great fun to be able to do stupid things to make events happen. Thank you, Matthew.
Okay.
Cool.
Thanks a lot.